Welcome to Science and Engineering World, where we have fun doing mathematics, more mathematics, much more mathematics. In this presentation, I want us to look at the solution to a simple problem to demonstrate the use of hyperbolic identities. My name is Olutola Fakehinde. The statement of the problem is that if 5 exponential e to x minus 4 exponential e to minus x is identical with a sinhx plus b coshx, what are the values of a and b? Let us first define what sinhx and coshx are. Sinhx is hyperbolic sine of x, and sinhx is therefore defined as e to power ex minus e minus x over 2. Okay. Coshx is also hyperbolic cos of x, and so coshx is equal to e to x plus e to minus x all over 2. With sinhx and coshx identified, we can now write the expression as 5 e to x minus 4 e to minus x equal to a into e to x minus e to minus x over 2 plus, that's for sinhx, plus b into e to x plus e to minus x over 2 for coshx. This we can then write as bringing the denominator out, we can write as a over 2 into e to x minus e to minus x plus, again bring the denominator out, b over 2 into e to x plus e to minus x. Let us expand the brackets. So we're going to have a over 2 e to x minus a over 2 e to minus x plus b over 2 e to x plus b over 2 e to minus x. So let us collect the like terms of e to x and e to minus x together. So we're going to have here a over 2 e to x plus b over 2 e to x. Then we have minus a over 2 e to minus x plus b over 2 e to minus x. Okay, we can write them in this form and say that e to x, we can bring it out, so we have a over b over 2 plus b over 2 into e to x minus bracket a over 2. Now because this is plus, so we're going to put minus here, because minus times minus is going to give us the plus here, and then plus b over 2 e to minus x. With close observation, we see that the expression on this left hand side is looking similar to the expression here. Now we can equate the coefficient of e to x on this side, on the left hand side, with the e to x on the other side, and then we'll do the same thing for e to minus x. Equating the identity, we can then say here that 5 equals to, for the other side, we have a over 2 plus b over 2. If we multiply this expression by 2, we are going to have 2 multiplied by 5 equals to 2 multiplied by a over 2 plus 2 multiplied by b over 2, and this gives us 10 equals to a plus b. Good. So let's call this 1. For e to minus x, we can now write minus 4 equals to minus a over 2 plus b over 2. Again, multiplying this by 2, we're going to have 2 into minus 4 will be equal to 2 into minus a over 2 plus 2 times b over 2, and this gives us minus 8 equals to minus a plus b. expression 2. Let's bring the two expressions together. We have 10 equals to a plus b, and then we have minus 8 equals to minus a plus b. So if we add, this is a simple simultaneous equation, and if we add the two equations together, we are going to have here 10 minus 8 is going to be 2, which will be equal to a minus a is 0, and then we have b plus b equals to plus 2, thereby we have b equals to 2 divided by 2, which is equal to 1. So our b is 1. So we have the value for b, which is equal to 1. And we can put this value of b into any of the equations. We can put it in equation 1. In that case, we are going to be having 10 equals to a plus 1. Therefore, a equals to 10 minus 1, and a is now equal to 9. So the value for a is 9. That is the solution to the problem, where we find the values of a to be 9 and the value of b to be 1. Okay, I hope you have enjoyed the short demonstration of hyperbolic identities. If you do enjoy it, please give us a like, thumb up, share this link to others, make comments so that you can know there are other methods to use, and then please subscribe. Press that button. It's important for this channel. Please subscribe, and then keep having fun. And until we meet next again, keep studying.